Hello everyone, welcome to SHR Trinity. Welcome back to the Generative AI Interview Questions series by SHR Trinity. In this part, we continue our journey through the most important generative AI interview questions frequently asked in technical interviews. In this video, we focus on concepts that are highly relevant for AI engineers, machine learning engineers, data scientists, software developers, and generative AI professionals. Each topic will be explained with practical examples, visual diagrams, architecture discussions, comparison tables, and interview-focused insights. Before we begin, subscribe to SHR Trinity and hit the bell icon so you never miss any updates from our end. Now let's continue with today's questions. We are also excited to announce the Generative AI Comprehensive Hands-On Training Program by SHR Trinity. This is a 30-hour intensive course featuring 20 live sessions of 1.5 hours each, held Monday to Friday from 7:30 p.m. to 9 p.m. The program commencement date is May 11, 2026. The curriculum covers foundational concepts of AI, machine learning, and deep learning, moving into LLMs, local GPT-2 deployments, prompt engineering, RAG pipelines, autonomous crew AI agents, Langflow workflows, and model context protocol. The course fee is 15,000 rupees. To enroll or learn more, contact us at contact@shrtrinity.io or call us at +91 70956 78789. In this session, we transition into how large language models are integrated with external databases and cognitive agent loops to build production systems. We will define retrieval-augmented generation, explain its advantages over fine-tuning, details the core RAG components, and explain vector databases and FASS. Finally, we will cover Graph RAG with Neo4j, define autonomous AI agents, introduce the Crew AI framework, and compare agentic systems with traditional software architectures. Question 31. What is retrieval-augmented generation? Retrieval-augmented generation, commonly referred to as RAG, is an architectural pattern that enhances the capabilities of a large language model by connecting it to external databases. Instead of relying solely on the static facts memorized in the model's weights during training, a RAG system first retrieves relevant documents from a database based on the user's query. It then wraps these retrieved document snippets along with the original user query inside a structured prompt. The model reads this augmented context and generates a response based on the factual documents provided. RAG is the industry standard for building question-answering systems over private company files, as it ensures accuracy and provides clear source citations. Question 32. Why do we need RAG? Look at the comparison table on screen. Standalone large language models suffer from three major limitations: they hallucinate facts, they have knowledge cutoff dates, and they cannot access private corporate data. To address these issues, we can either fine-tune the model or use RAG. Fine-tuning is like studying for a closed-book exam. It is slow, computationally expensive, and requires retraining the model every time information changes. RAG, on the other hand, is like an open-book exam. It fetches relevant documents instantly from a database, making it easy to update knowledge, access private files, and completely eliminate hallucinations by grounding responses in verifiable facts. Question 33. What are the components of a RAG system? A production-grade RAG system is divided into three main pipelines. First, the ingestion pipeline, where raw documents like PDFs or Word files are parsed, broken down into smaller text chunks, converted into vector embeddings, and stored in a vector database. Second, the retrieval pipeline, where a user's question is converted into a vector using the same embedding model, and a mathematical similarity search is performed against the database to fetch the top k most relevant text chunks. Third, the generation pipeline, where the system merges these retrieved text chunks and the user's question into a prompt template, which is sent to the LLM to generate a factual, contextual response. Question 34. What are embeddings in RAG? In a RAG pipeline, vector embeddings are the foundation of semantic retrieval. Before documents are stored, They are broken down into smaller text segments called chunks, typically around 500 characters with minor overlap. An embedding model converts each text chunk into a high-dimensional vector. When a user asks a question, the system converts that question into a vector using the same embedding model. Because both the query and the document chunks exist in the same mathematical space, the system can use cosine similarity to find matching context. This enables semantic search, meaning a query about medical leave will successfully retrieve documents about sick policies even if the exact words do not match. Question 35. What is a vector database? Look at the comparison table. Traditional databases are designed to store structured tables or JSON documents and query them using exact keyword matches. However, they struggle to search high-dimensional vectors at scale. A vector database is specifically optimized to store, manage, and index vector embeddings representing unstructured data like text, images, or audio. They utilize specialized approximate nearest neighbor indexing algorithms, such as hierarchical navigable small world, or HNSW, to search through millions of vectors in milliseconds. They also support metadata filtering, allowing you to restrict searches to specific document categories, dates, or user permissions. Question 36. What is FASS? FACE, which stands for Facebook AI Similarity Search, is an open-source library developed by Meta's research team. Written in highly optimized C++ with native Python wrappers, FACE is designed for fast similarity search and clustering of dense vectors. Unlike managed vector databases, FACE runs directly in your application memory, making it ideal for local prototyping, offline analysis, and lightweight RAG applications. It supports multiple index types, including index flat L2 for exact distance calculations and index IVF flat for clustered, approximate search. Look at the code on screen. We initialize a flat index, add randomly generated vectors, and query for the 5 closest matches. Question 37. What is Neo4j and GraphRAG? Standard vector search retrieves isolated text chunks, which can fail to answer complex, multi-hop questions like, how is Project Alpha connected to Team Bravo? GraphRAG resolves this by combining vector search with a graph database like Neo4j. In a GraphRAG system, documents are parsed to extract entities, such as people, projects, and organizations, which are stored as nodes, and their interactions, which are stored as edges. When a query is received, the system retrieves the relevant vectors and traverses the graph relationships, providing the LLM with a structured map of how entities are connected. This enables the model to answer complex relational questions with high accuracy. Question 38. What are AI agents? AI agents represent a shift from passive conversational chatbots to active, autonomous systems. An AI agent uses a large language model as its central brain or cognitive engine. When given a high-level goal, the agent does not just output text. Instead, it enters an iterative planning loop. It breaks down the goal into smaller tasks, decides which external tools to call, such as web search, Python execution, or SQL queries, analyzes the tool's outputs, and adjusts its plan until the goal is achieved. This ability to reason, call tools, and handle errors autonomously makes them highly effective for automating complex workflows. Question 39. What is CrewAI? CrewAI is a popular open-source multi-agent framework designed to orchestrate groups of collaborative AI agents. Instead of building one massive agent to handle everything, CrewAI encourages you to create a team of specialized agents, much like a human corporate department. You define each agent with a specific role, a clear goal, a descriptive backstory, and a set of tools. Agents can then work together, passing data between tasks, delegating subtasks, and collaborating to solve complex problems. Look at the code. We define a researcher agent and a writer agent, assign them sequential tasks, group them in a crew, and run the workflow using crew.kickoff. Question 40. Agentic AI versus traditional AI systems. Look at the comparison table on screen. Traditional software and AI systems are deterministic, developers write explicit conditional loops, and APIs are called along predefined, hard-coded paths. If a user input deviates from the plan, the system throws an exception. In contrast, agentic AI systems are probabilistic and adaptive. The control flow is driven by the LLM's reasoning engine. The agent dynamically decides which tool to call, analyzes the output, and can self-reflect to correct errors and try a different approach if the first attempt fails. This makes agentic systems highly flexible but harder to test and evaluate. Thank you for watching. If you found this video useful, please subscribe to SHR Trinity for more videos, and click the like and share buttons. Stay tuned for Part 5, where we will cover advanced generative AI, model context protocol, and real-world scenarios. If you are interested in attending our live training sessions or have any inquiries, all our contact details are displayed right here on screen and are also available in the video description below. Feel free to reach out to us. We would love to have you as part of the SHR Trinity learning community. See you in the next video.